Good
afternoon, sir.
Okay, let us start. Actually, internet speed is not good today. Anyway, let us start. Today we shall start a new chapter, chapter 2. Okay, that is origin and evolution of the art. Yesterday I have seen the study material, and today we shall start the discussion on the concepts. Now I shall share my screen. I think somebody is keeping on his or her microphone. Please turn it off. When you want to ask question, you may turn on it. So this is the chapter, the origin and evolution of the art. Okay, can you see my screen, the textbook? Okay, see. So since our childhood, we have been wondering about the stars, about the celestial bodies in the sky. Okay, how these were originated, and so today we shall discuss about it, about the origin of the art and about the origin of the universe. And regarding the origin of the celestial bodies, including art or the origin of the universe, we have two theories. Okay, two categories of theories. So we have early theories and we have modern theories. Okay, so first let us discuss about the origin of the art. That is early theories. Okay, about early theories about the origin of the art. So a large number of hypotheses were put forward by different philosophers and scientists regarding the origin of the art. Do you know the meaning of hypothesis? Actually, hypothesis, this is the plural form of hypothesis. Okay, do you know the meaning of hypothesis?
No, sir.
See, okay. Hypothesis, you know, this is supposition, okay? Is a kind of supposition about a phenomenon and say when it is proved, when it is found true, we call it theory. So a large number of suppositions, large number of hypotheses regarding the origin of the art, regarding the origin of the universe, okay, have been put forward by different philosophers and by different scientists. So one of the earlier, okay, and a popular argument was made by German philosopher Immanuel Kant. Okay, Immanuel Kant, very famous German philosopher, and his argument was also popular. His hypothesis was also popular, and the mathematician Laplace revised it in 1796, and the name of the hypothesis is known as this nebular hypothesis. Okay, a nebular hypothesis. And this hypothesis considered that the planets were formed out of a cloud of material associated with the youthful sun, which was slowly rotating. You know, cloud here means the stellar cloud. Okay, stellar cloud. See here, we have a diagram. So according to this nebula hypothesis, there was a cloud revolving around the sun. Okay, there was a cloud revolving around the sun. So here, let me zoom it. See here, and here, see, there was a cloud. Okay, so let us suppose this is the cloud, and so self-gravity attracts a gas cloud. Because of self-gravity forms a gas cloud, a stellar cloud consisting gases and dust particles. Okay, gases mainly helium and hydrogen. Then see, conservation of angular momentum pulls the cloud into a disk. Conservation due to when the size, when the size of the cloud is reduced or contracted. Okay, when a cloud is contracts, when a rotating cloud is contracts, then the angular velocity will be increased. That is the point mentioned here. Okay, let us suppose this is the cloud and it is rotating on its own axis. I think you may be seeing the arrow also, and see the size of the cloud is decreasing. That means the cloud contracts because of self-gravity, and when it contracts, the angular velocity increases. Okay, and the central mass here, the material here at the center of the cloud forms the protosun, and this centrifugal force balance the gravitational force, and a rings forms, and these rings, okay, see here, a ring was formed here. A ring was formed. Actually, I think you are seeing the ring here. So a ring was formed around the sun, and from these rings, okay, from these rings, different planets were formed from this ring. And see here, see, one thing you have to know, centrifugal force, what is this? Balance the gravitational force. Say, for example, in this case, so here we have the object, we have the cloud, and so self-gravity attracts it towards the center. So this is the center, and it is every object or every particle is attracted towards the center, and this is known as gravity, okay, or centripetal force. And as we have discussed that this cloud is rotating, and because of rotation, see, when, see, for example, see, here we have one person, and this person is holding a stone at the end of a string, and when he or she rotates this stone round himself, then this stone will pull his hand, and that force, the tendency to move away from him or herself, is known as the centrifugal force. And so here in this case, this gravity is balanced by the centrifugal force, and hence that ring of cloud is revolving around the protosun, and from that ring, okay, different planets were formed. So this is about nebular hypothesis, as mentioned here. Okay, and it was propounded by German philosopher Immanuel Kant, and revised by this Laplace. So any question, boys and girls? If you don't have questions, so let us continue. So later in 1900, Chamberlain and Moulton, okay, Chamberlain and Moulton considered that a wandering star approached the sun. So this is what I call wandering star hypothesis. Chamberlain and Moulton considered that a wandering star approached the sun, and as a result, cigar-shaped extension of material was separated from the solar surface. And as the passing star moves away, the material separated from the solar surface continue to revolve around the sun, and it slowly condenses into planets. So this is another hypothesis We call it wandering star hypothesis, propounded by Chamberlain and Moulton in 1900. And see here, so this is the diagram. Okay, so let me zoom it. And here, see, so here we have the sun. Okay, here we have the sun and a wandering star. A star is passing nearby it. So this is the wandering star, moving star, and this star is passing nearby the sun. And you know, so when the star passes nearby it, then it say it pulls out materials from the sun. Okay, when so it pulls out materials. Okay, from the sun, and these stars continue to move away, and because of this force of the wandering star, then these materials continue to revolve around the sun. Okay, as in this way, and in due course of time, from these materials, from this cloud or the sun material, so different planets were formed after condensation. Okay, so this is what I call wandering star hypothesis. And Sir James Jeans and later Harold Jeffrey supported this argument. Okay, and later that the arguments considered, okay, at a later that the arguments considered a companion to the sun to have been coexisting. So this is another hypothesis. We call it binary star hypothesis. So according to this hypothesis, the sun and the companion star have been coexisting. Okay, have been coexisting means together, living together, just in this way. This is about binary star hypothesis, and just see here, and here we have the sun here. Okay, we have the sun. Sun is here, and this is the companion star. Okay, here we have the companion star, and so these, our sun and this companion star were coexisting. Okay, so revolving around the sun means moving each other, revolving around each other, and another star, okay, intruding star is coming nearby it. I think you are seeing here, and it is moving towards this direction. And when this intruding star comes nearby the companion star, say a filament material from the star will pull out, and from the accretion process, okay, from by condensation or accretion process, the different planets were formed from these matters. So this is what we call binary star hypothesis. Okay, and in 1950, Otto Scheme in Russia and Carl Wiesecker in Germany somewhat revised nebular hypothesis. So Otto Scheme and Carl Wiesecker revised nebular hypothesis. Okay. And see, through differing in detail, so they considered that this Otto Scheme and Carl Wiesecker considered that the sun was surrounded by solar nebula, that is cloud containing mostly hydrogen and helium, along with what may be termed as dust, that is stellar dust. Okay, that will lead to the formation of the star and other objects. And the friction and the collision of the particles led to the formation of disk-shaped cloud, and the planets were formed through the process of this accretion. So here we have one more diagram. So this is about a revised nebular hypothesis. Okay, so here we have the sun is here, okay, and it was surrounded by these rotating these cloud, okay, disks of gas and the dust. Okay, so this was the youthful sun, and when we magnify it, so it looks like this. And see, within these clouds, okay, these dust grains, okay, dust grains clump together to form planetesimals, a bigger one, okay. Within it, bigger these particles were formed. See here, so for example, this is the cloud containing hydrogen, helium, and other these stellar dust. I think you may be seeing that some of the dust particles are bigger than the others, and the bigger particle attracts the smaller one towards it. And in this process, this will grow. This process is known as accretion. Okay, accretion. And because of this process, okay, these dust grains will clump together to form a bigger particle. We call it planetesimal. And in due course of time, okay, this is the planetesimal. This planetesimal will attract these dust particles, other smaller particles, and the gas particles, and so these planetesimal will grow in due course of time, leading to the formation of different planets, okay, around the sun. So this is the sun. So this is what explained by these people, Otto Scheme and Carl Weizsäcker. Okay, see, through the friction and a collision of the particles lead to the formation of disk-shaped cloud. I think you have seen in the diagram, and a planet were formed through the process of accretion. Means as you have seen in the diagram, okay, as you have seen here, the bigger particles attract. See here, the bigger particles attract the smaller particles. That process is known as accretion. And because of accretion process, collision and accretion process, the planets were formed. Okay, so this is about the revised nebular hypothesis. Up to here, any question, boys and girls? Are you clear? Yes, Ricky, any question?
No, sir.
Okay, actually today internet is not good, and so I think my voice may not be clear also. Anyway, let us continue. And so next we have modern theories. So we have discussed the early theories, okay. And then next we have modern theories, and this is about the origin of the universe. Actually, you must know that our art is not independent of the universe. Okay, so when the universe was formed, then originated these stars, then planets and other asteroid celestial bodies were also formed. Okay, so we better to discuss about the origin of the universe. And the most regarding the origin of the universe, the most popular argument regarding the origin of universe is the Big Bang theory, which you might have learned in the science classes also, in the lower classes. And this Big Bang theory was also known as expanding universe hypothesis. Edwin Hubble in 1920 provided evidence that the universe is expanding. Okay, so Edwin Hubble, a scientist in 1920, gave evidence that our universe is expanding, increasing in size. Okay, the distance among the stars and the galaxies increasing. And as the time passes, galaxies move further and further apart. So you can do experiment, by taking a balloon. Okay, just here, take a balloon and mark some point. Just let us say here we have the balloon. Okay, and let us mark some points here. And Now, if you start inflating the balloon, then the points marked on the balloon will appear to be moving away. So when you inflate the balloon, okay, see here the size of the balloon will grow in this way, and so the distances here will be increased here. Okay, the distances among the points will be increased. So in this way, the our galaxy, okay, the distance between the galaxies in our universe, okay, has also been increasing. So this is what I call expanding universe hypothesis. Okay.
Sir, how is it in?
Actually, we are going to discuss about it, because when we discuss about the origin of the universe, and you will know that why it is increasing. And I think about the balloon you might have clear. So this is the balloon, and just put some marks here. And when we inflate it, then the balloon, okay, the size of balloon will grow like this, and the distance among the points will be increased. So this is just an uh, example, okay, just an experiment. However, actually, uh, just for to understand the concept, we are telling like this. Actually, it may not be like this also. Now, so about why the distance among the galaxies has been increasing, so we shall discuss now. Okay, and see here, we have this is the figure regarding the Big Bang theory. Okay, so let us read. So the Big Bang theory considers the following stages in the development of the universe. Okay, we have three stages mentioned in our book regarding the origin of the regarding the development of the universe. So in the first days, in the beginning, okay, in the first days, all the matter forming the universe existed in one place in the form of a tiny ball. We call it singular atom. Okay, just here. I think you may be seeing here. All the matter forming the universe existed in one place in the form of a tiny ball, okay, a small ball. We call it singular atom with an unimaginably small volume, infinite temperature, and infinite density. So the size, the volume of the object ball was okay, small, very small, and infinite temperature means a temperature not steady, sometime increasing, sometime decreasing. Okay, infinite, and density also changes frequently. That was the nature of the small object, that is tiny ball. So in the geography of Puranas, actually, when you learn geography in the postgrad level, so you will learn about geography of Puranas under the paper geographical thought. So in the geography of Puranas, our ancient Indian scholars call it Adi Purusa. Okay, this tiny ball was known as Adi Purusa, singular atom. So that was the beginning, and I think you have seen here. So this is the singular atom. So at the Big Bang, okay, in the second stage, so the tiny ball exploded violently. Suddenly, the tiny ball was exploded because the volume was okay, change from time to time. Temperature also not steady, okay, infinite, and that is why suddenly the tiny ball exploded violently, and because of the explosion, okay, this led to a huge expansion of the matters, okay, in the space. And now it is generally accepted that the big explosion took place 13.7 billion years before present. The Big Bang, okay, the huge explosion, the violent explosion took place 13.7 billion years before present. The expansion continues even present day, and that is why it will Hubble in 1920 found that our objects, our celestial bodies in the sky, he found expanding mean distance among the celestial bodies expanding. means increasing, okay, because of that explosion. As mentioned here, the expansion continues even to the present day. And as it grew, the energy, some energy was converted into matter. Okay, when expansion continues, some of the energy converted into matter. Okay, and there was particularly rapid expansion within the fractions of a second after the bang. So immediately after the bang, after the explosion, the expansion of the matters were rapid, and thereafter the expansion has slowed down. And within the first 3 minutes from the Big Bang, okay, within the first 3 minutes from the Big Bang, even the first atom began to form. So this is about second stage. And in the third stage, within 300,000 years from the Big Bang, the temperature dropped to 4,500 Kelvin and gave rise to atomic matter, and the universe became transparent. That means light was born. Okay, actually, in the beginning there was darkness everywhere, no light. There was darkness, and so in some place there was a small tiny ball. We call it singular atom, and suddenly that singular atom having this unimaginably small volume, infinite temperature, and infinite density exploded suddenly. And because of that, the expansion of matters took place. Then atoms form. Okay, then within 3,000 years, within the bang, temperature dropped. Okay, and the universe became transparent. And actually, see here, here we have the diagram. Explosion is here, then expansion. So this ring, okay, this object represents a galaxy here, I think. And because of the expansion, the distance among the galaxy here increasing. Okay, so these are the galaxies here, another galaxy, another galaxy. Because of this expansion, so the distance among the galaxies increasing. And here also, see here, so this is the Big Bang. Okay, this is the Big Bang. And here, so within these 3 minutes, this formation of light elements there. Okay, and here 380,000, actually in our book 300,000 years mentioned. So here we have formation of atoms. Okay, and here this is the present day. So this is the present day universe. So this is regarding Big Bang theory, and this expansion of universe means increase in the space between the galaxies, as you find here. Okay, see, there is increasing space between the galaxies. This is what I call expansion of universe. And an alternative hypothesis is also there, propounded by Whale. Okay, Whale, and his concept, his hypothesis was known as steady state, and it considered the universe to be roughly the same at any point of time. However, greater evidence from becoming available about the expanding universe. Scientific community at the present favors argument of expanding universe. So most of the scientists favors expanding universe hypothesis, because we have the proof that, okay, in the space we have a space Hubble telescope. Okay, is a radio telescope, and this telescope also observes that the distance among the galaxies or heavily these celestial bodies increasing. So any question regarding the Big Bang theory? Boys and girls, are you clear? Do you have questions?
Yes, sir.
Okay, then if you clear, so let us stop here for
Voice
today.
not clear, sir.
Yes, I cannot hear you. Tell me.
Yes, sir. Ale, kecil. Ale, kecil.
Your voice is not clear.
Huh? Sir, your voice not clear.
Okay.
I love you.
Then means I have told you in the beginning that today that due to broadband internet failure, so internet speed is very slow. I'm using a network, and that is why. Okay. So I shall upload this explanation in the YouTube, and so you may watch it again to have a clear idea. Okay. So thank you very much.
Yes, sir.
Thank you for joining my class.
Thank you, sir. Have a nice day, sir.
Okay.